Okay, so in this video I'm going to have a look at the 2016 Maths Higher Level Paper 2, and I'm going to have a look at questions 4 and 5. So this is the first one here. We have a diagram and it shows a semicircle standing on a diameter AC. So this is our diameter along here, AC, and we have BD, this line here, which is perpendicular to AC. We've got to prove that triangles ABD, that's this triangle here, and this triangle here, BDC, are similar. So there are a couple of ways of doing this. You did this in junior cert when you proved Pythagoras Theorem, so that could be one line we'll go down, but we'll have a look at another way. Let's just have a look at what we've got here. We have this triangle and we have this triangle here, and we can see that we have two right angles here. So we can say straight away that the size of the angle ABD is equal to the size of the angle DBC. They're both equal to 90 degrees. So ABD and DBC are both 90 degrees. So we have one angle anyway that's the same in both triangles. Now let's just have a look at this angle here. If we have a look at this angle here, which is ADC, that angle there is an angle in a semicircle. In other words, it's 90 degrees. It's an angle standing on the arc that the diameter is standing on, if you like. If you complete this circle here, the diameter is standing on the bottom part of the circle, and so is this angle here. Now we know that the diameter is 180 degrees, so therefore this angle here must be 90 degrees. So ADC is 90 degrees. In other words, we can say that the size of the angle ADB plus BDC is equal to 90 degrees. So in other words, this angle here, ADB, and this angle here, BDC, they add up to 90 degrees. Now let's just move this up a little bit. Okay, so we know that this angle here, these two angles added together are 90 degrees. Now if you take this angle, we've already shown that this angle here is 90 degrees, DBC is 90 degrees. That must mean that the other two angles here, this one here and this one here, added together must give us 90 degrees as well, because the three angles in a triangle add up to 180 degrees. So this angle here, BDC, so we can say the size of the angle BDC plus, so BDC and this angle here, BCD, must also give us 90 degrees. So if we just combine these two here, we can see that if these two added together give us 90 degrees and these two added together give us 90 degrees, then these must be equal. In other words, the size of the angle ADB plus size of the angle BDC must be equal to the size of the angle BDC plus BCD. So you can see here we have a BDC on this side, we have a BDC on this side, so we can just subtract that from both sides, and that will just give us that the angle ADB must be equal to the angle BCD. So ADB, in other words, this angle here, ADB, must be equal to the angle BCD, this angle here. So we've shown that these two angles here are equal. These two are both 90 degrees. We've now shown that these two angles here are equal. So therefore the third angle, this one here, must be equal to this one here. Therefore the two triangles are similar. So really, when you're proving that triangles are similar, you just really need to show that two of the angles are the same, then the third one must be the same. So we could write that out. We could say, therefore, the size of the angle DAB is equal to the size of the angle BDC. Therefore, I'm kind of running out of room here, but to keep this in the picture here. But we've proven this now. You could just say, therefore, let's just put it up here. Therefore, triangles ABD and DBC are similar. So you would write that down here at the end. Okay, so I think that's about it for that one. Do I need to do anything else? Yeah, just one thing here actually I should say. When you're writing this out here, probably should have said this earlier, when you make a statement like this, this angle is equal to this angle is equal to 90 degrees, you need to write a reason here, and the reason here is you're given that in the question. ADB plus BDC is equal to 90 degrees, so that's this angle here, and BDC, this angle here, equal to 90 degrees. You would need to make a statement there like angle in a semicircle. So you'd need to say something like that. Rather than just writing it down, you'd need to give a reason as well. Then these two here, BDC plus, so that's BDC, that's this angle here, and BCD, this angle here, give you 90 degrees. So the reason there, you would just say something like angles in a triangle. Angles in a triangle equal 180 degrees, because we already know this is 90 degrees here. So when you make a statement like this, we'll give a reason as well. I haven't done it very well here, but put your mathematical statement here, and then the reasons on the right hand side. Okay, so let's just move on. Now we have here, if AB is equal to x and BC is equal to 1 and BD is equal to y, write y in terms of x here. So they're saying here that if AB is equal to x, so there's an x here, and then they're saying BC is 1, so this distance here is 1, and BD is y, so BD is actually this distance up along here. Write y in terms of x. So I'm just going to redraw that. Actually, what I might do first is just move this up a little bit, give myself some room, and let's just redraw that triangle with these conditions in there. So we have our triangle that looks something like this, and we have this distance down along here. So we were told that this distance here is x, this distance here is 1, and this distance here is y, and we're told this is a right angle, this is a right angle here. So this is AB is x, so this is b here, I think, from what I can remember. Let me just double check that. ABC along here, and we got D up at the top then. So we have AB, and we have C here, and we have D up here. Okay, so let's work through this. Now, I'm just going to call, we have all the sides identified here except these two, so I'm just going to call this, let's say, M, and I'm going to call this side here, let's say, N. I'm going to write a few equations here. So let's take M here and write that in terms of y and x. We have a right angle triangle here. So let's say then that m squared is going to be equal to y squared plus x squared. So that's this triangle here on the left hand side. We have another triangle here on the right hand side, so I'm going to say n squared, our hypotenuse, is just going to be equal to y squared plus 1 squared. Now we also have our big triangle here, the main triangle ACD, so that's a right angle triangle as well, given that we had our semicircle here, so this is an angle in a semicircle, so this is a right angle here, we had that earlier. So this big triangle is a right angle triangle. So I'm going to apply Pythagoras Theorem as well here. So we can say here that x plus 1, which is the hypotenuse here, we can square that. That's going to be just simply equal to m squared plus n squared. Now let's just expand all of this. If we expand the left hand side here, we get x squared plus 2x plus 1. Now the right hand side is an m squared. We have an m squared here. We know that that's equal to y squared plus x squared. Y squared plus x squared. We have an n squared here. We know that's y squared plus 1 squared. Y squared plus 1 squared. So all we've got to do now is just simplify this. Remember, we've got to get y in terms of x. So we have our y here, we have a y here. So let's see what we can simplify. Now we have an x squared on the left hand side, we have an x squared on the right hand side, both plus. So we can just subtract from both sides our x squared. We have a plus 1 on this side, we have a plus 1 on this side. The plus 1 squared is just 1. So we can subtract 1 from both sides. So what are we left with? We're left with 2x on the left hand side, and we're left with y squared plus y squared, which is just 2y squared on the right hand side. I'm going to just divide across by 2, so we get x is equal to y squared. So that will just give us y is equal to the square root of x. So in other words, this distance here, this distance from here to here, is just the square root of this distance here. I'm going to use that, I think, in the next question. So the y is equal to the square root of this distance here, x. Okay, so let's move on then. We have this here. Okay, using your result from part A2, so that's the bit we did just up along here. Construct a line segment equal in length in centimeters to the square root of the length of the line segment TU. So this, we want to construct a line that's the square root of this distance here. Now, if you remember our triangle from the previous part, we had our triangle that looked like this. We had a line coming down here, and we had our y here. No, we didn't. We had our y. That was x, I think. This is our x, and this was our y here. And this was a right angle. This was a right angle here. And we discovered that y is equal to the square root of x. So this distance here is the square root of this distance here, and that's what I'm going to apply here. I'm going to construct a line up along here from u. I can call that y as well, and that's going to be the square root of this distance here. So I've got to recreate this entire thing here. We know also, by the way, that this was 1. This distance out here from here to here was 1. I think we had, what did we call them? We had A, B, C along the bottom. So we had an A, B, C along the bottom here. So this was A, this was B, and this was C here. So what you're going to do here really, and I've got to do this freehand, you guys have to use a ruler and compasses and so on. I have to do this freehand. So what you're going to do is you're going to start here, and you're just going to extend this out, and you're going to call it, well, we can call it whatever we want, let's call it M, for example, and we're going to say that that's 1 centimeter. You've got to construct this so that that's 1 centimeter in length. So you'll get your ruler and you'll just draw a line out here that's 1 centimeter in length. I'm doing this freehand, so I don't have a ruler. I'm not doing this exactly 1 centimeter. Okay, so the next thing you've got to do, remember we had a kind of a semicircle. Well, we had a semicircle going around here like this. So we've got to recreate that as well. Now, in order to do that, we've got to find the center of this line segment TM. So in order to find the line segment, the center of the line segment TM, what we've really got to do here is do a perpendicular bisector of this line. And if you remember that from your constructions, you get your compass, you put the point a bit here, you bring your pencil more than halfway out, you'll draw an arc up here. You'll put the point a bit here, you'll draw another arc up here, and then you'll do exactly the same without moving the compass in or out. You'll do exactly the same down here as well. And then you'll construct a line segment down along here, from here to here. And where that line segment crosses the line segment TM, that's your center point. Okay, so now we have our center point of our line segment TM. So put your pointy bit here, if you like, of your compass, and you're going to draw a circle around, or semicircle I should say, around here. Now again, I'm doing this freehand, so forgive me if it's a little bit off, but it should, let's see, it should come up along here and back down here. Okay, not too bad. Okay, so now we have our semicircle. This is our semicircle here. Next thing we've got to do then is just draw our Y. Draw the line Y here. So what we're going to do is just, now you can do this, it has to be perpendicular to TM. You can do that a couple of different ways. Again, you can just put a set square here, just get your triangle shaped set square, put it here and just draw a line directly straight up here, and that'll give you your line Y. The other way you can do it is use your compass, your construction, drawing a perpendicular line through a point. So remember how to do that. You might need to extend this out a little bit here, but you put your pointy bit here, you draw an arc here, you draw an arc out here, and then you put the pointy bit here, you end up drawing an arc up here, put the pointy bit here, draw another arc here, and you end up drawing a line straight down here. That line should be perpendicular. That line should be perpendicular here. But a set square is just as good here in this situation. So what we find now is that this line here was our Y here, and we know from what we did in the previous section that that's the square root of TU. So we know that our distance Y, distance up along there, is going to be equal to the square root of the distance TU. Square root of distance TU. I think that's all we needed to do. Use the results from part A2, which is what we've done. Construct, which we have done. You need to show your construction lines here. A line segment equal in length in centimeters. So remember, this has to be 1 centimeter here. Okay, so when you were drawing this, use your ruler to draw 1 centimeter. In length to the square root of the length of the line segment TU, which is drawn below. So that's what we always started with here, was the line segment TU. We put in all these extra little bits. Okay, so that's it for part B. Let's have a look at question 5 then, the next question. Okay, in this case we have an archery competition. Okay, the team consists of John, David and Mike, so we have the 3 of them here, and they will win first prize if at least 2 of them hit the bullseye with their last arrow. At least 2 of them must hit the bullseye. From past experience, they know the probability that John, Dave and Mike will hit the bullseye on their last throw is, so these are the probabilities. This is the probability 1/5 that John will hit the bullseye is 1/5 with his last arrow. Mike 1/6, and no, Dave 1/6 I should say, and Mike 1/4. Complete the table below to show all the ways in which they could win first prize. So let's just tick them off. So this is one way. John could hit first with his last arrow, and then Dave with his last arrow, and then Mike will miss. You could have, let's see, whoops, that's the wrong one. Let me just get rid of that. So we could do this one. Dave could miss and Mike could hit. We could have, let's see, John missing, Dave hitting, and Mike hitting. And then remember, it says here that at least 2 of them could hit the bullseye with their last arrow. So if theoretically all 3 could hit. So we could have this situation here. All 3 of them could hit with their last arrow. So that's part A1 done, really. Hence or otherwise, find the probability that they will win the competition. So winning the competition is, a combination of all these different scenarios here. So let's write out all the probabilities. So let's see what way this can work. Now, in the first case here, we would say that John will hit with his last arrow, and David will hit with his last arrow, and Mike will miss with his last arrow. So what are the probabilities there? So the probabilities are just simply John was 1/5 that he will hit, and means you multiply. David will also hit. His probability was 1/6, and Mike needs to miss. Now Mike hitting was 1/4, So missing then would be just simply 3/4. So we're just going to put in 3/4 here. Okay, so that's the first possibility. Now the next possibility is this one here. So you would say or means you add in probability. So we're going to look at John hitting, which is 1/5. David missing, so that's going to be 5/6. Remember, hitting was 1/6, so missing is 5/6. And then we want Mike to hit, so that was 1/4. Next possibility then is this one here, or again. So we want John to miss, so that's going to be 4/5. We've got 4/5, and we want David and Mike to both hit. So that's going to be 1/6 and 1/4. 1/6 and 1/4. And the last one then, we want all three to hit. So that's just simply going to be 1/5 times 1/5. Oops, I'll do that again. So it's going to be 1/5 times 1/6 times 1/4. Okay, so this is our probability really that they will win the competition. So you just got to do each of these. It's all just calculator work after this. So if you do this, you get 3/120. If you do this one, you'll get this one here, you'll get 5/120. If you do this one here, you'll get 1/120. And if you do this one here, you get 13/120. And if you add all of those up, you finally get 13/120. So that's equal to the probability that they will win. They will win the competition. And that's it really. That's part 2 done. Okay, we should have another bit here. We do. Okay, part B. Now, in this particular case, we're not given a story as such. It's a non-contextual kind of question. So let's work through this. We have two events A and B. They're represented in this Venn diagram here. The probability of A intersection B. The probability of A intersection B is 0.1. So we can see that's here. The probability of B less A is 0.3. So everything in B would exclude A. So we've got to exclude. Whoops. We've got to exclude this 0.1. So it's just 0.3 here. Now the probability of A less B is X. So this is A, take out B, and we're just left with X here. Write the probability of A in terms of X, and hence or otherwise find the value of X for which the events A and B are independent. Okay. So the probability of A, we want to write the probability of A in terms of X. Well, the probability of A is just simply X plus 0.1. This is the probability of A here, X plus 0.1. So that's it, very simple. Second part, hence or otherwise. Well, let's use the hence bit anyway. Find the value of X for which the events A and B are independent. So for events to be independent, we have the probability, your formula for independence, if you like, is the probability of A intersection B is equal to the probability of A times the probability of B. So if this equation holds in this particular scenario here, then we have independence. A and B are independent. Well, we know in A intersection B is 0.1. So we have the left hand side. The right hand side, the probability of A here, we've worked that out. That's just X plus 0.1. The probability of B here is 0.4. It's just these two here added, 0.3 and 0.1, which is 0.4. So what we've got to do here is work out what X is. So we have an equation here with X in it, no other variables, so we can just isolate X. So let's just work down through this. We have 0.1, we have 0.4X, and then we have 0.4 times 0.1 is just 0.04. Let's just bring the 0.04 over, so we get 0.06 on this side, and we get 0.4x on this side. Divide across by 0.4, and we get 0.04. 0.15 is equal to x. So that's our answer then, 0.15. So now we know what the probability of A less B is. A less B. Okay, and I think that was it. I don't think I have anything else down here to do. No, that's it. So that's it for this these two questions.